Listen, for the last year or so, a massive chunk of the AI community has been riding this wave of blind faith. People genuinely believe that large language models can magically fix their own reasoning if you just prompt them to double-check their work. But a groundbreaking new paper out of DeepMind and the University of Illinois just shattered this illusion completely. The realization here is honestly mind-blowing.
When there's no external feedback in the loop, no answer key, no tool, nothing but the model checking its own work, asking an LLM to self-correct its reasoning barely helps, and often makes things worse, not sometimes glitchy. The paper's own title calls this out directly. LLMs cannot self-correct reasoning yet. That "yet" matters. This isn't a law of nature, it's where today's models stand, and only in this specific setting. The stakes are still enormous.
Think about it. If we're blindly building autonomous agents and expecting them to self-correct on the fly in live production code or business analytics or, medical diagnostics,
We need to know exactly when that hope is justified and when it isn't. Spoiler, it comes down to one thing: external feedback, and we'll get to exactly what that means. Can AI actually fix its own mistakes? Right now, that's basically the billion-dollar question.
because if you've ever used ChatGPT, you've probably seen this happen. It makes a silly logic error. You reply with, "Hey, are you sure about that?" And it immediately apologizes and spits out a better answer. That feels exactly like self-correction, right? Well, researchers decided to rigorously test this exact phenomenon. But it turns out there was a massive catch in how previous scientists were measuring this capability. There was a shocking twist that artificially inflated all the hype. And we're going to get to exactly how they rigged the game in just a second. Section 1. Hype versus the reality. To really understand where this whole self-correction dream breaks down, we have to look at the problem researchers were trying to solve. The holy grail of AI right now is autonomy. Basically, having an AI catch its own bugs before it ever gives you a final result. So how did AI used to handle this? Think of it like taking a really hard math test. Intrinsic self-correction, which is what all the recent hype has been about, is like taking an advanced calculus test and then being told to grade it yourself, using only your own brain without actually knowing how to do calculus. If you didn't know how to solve the problem the first time around, staring at your own flawed logic isn't going to magically help. You're just guessing twice. External feedback, on the other hand, is like having a teacher grade your test with an actual answer key.
The huge blind spot in a lot of prior work was treating the AI as if it could be both the confused student and the expert teacher at the same time, with the same brain. So why did earlier papers claim massive self-correction gains? Here's the term that'll make you sound like the smartest person in the room: oracle labels. Prior studies were quietly using oracle labels, ground truth answer keys, behind the scenes. The AI would guess, a hidden script would check that guess against the real answer, and if it was wrong, the AI got told to try again. If it was right, the loop just stopped. See the problem? They were secretly telling the model exactly when to stop guessing. Take that answer key away, and the magic of self-correction vanishes. There's a second measurement trap buried in the literature: multi-agent debate. Some studies showed multiple copies of a model critiquing each other's answers back and forth produced big reasoning gains, branded as debate. But when the researchers controlled for the number of model calls, comparing debate against just generating several answers and taking a majority vote, called self-consistency, the debate advantage nearly disappeared. 9 model calls of multi-agent debate hit 83%. 9 calls of plain self-consistency hit 88.2%, actually beating it. The gains people credited to models critiquing each other were really just gains from generating more answers and voting, not self-correction. Self-consistency.
Section 2. How it actually fails. So what actually happens when we take those training wheels off? What happens when we force top-tier models like GPT-4 and Llama 2 to genuinely rely on their own internal logic? Well, the data is staggering. When you look at the breakdown of what happens after an AI is told to intrinsically self-correct, there is just a massive volume of failure. You see all these instances where the AI originally had the correct answer, but after being asked to review its own work, it actively changed its answer to an incorrect one. Without an answer key to confirm it was right, the model just caves under the pressure. It second guesses its perfectly good logic and literally breaks its own correct answer. Let's explain exactly how this happens like I'm 5, using a couple of math problems. Take the problem about Christina's birthday party. The AI is asked to calculate the cost of some gift bags. On its very first try, it gets the logic totally wrong and spits out $18. Then, the self-correction prompt kicks in. Review your previous answer and find problems. The AI actually manages to catch a mistake and fixes it to $24. Success, right? Awesome. But now, look at the other scenario, Terry eating yogurt. In this one, the AI gets the math flawlessly right on the very first try, $75. But when you prompt it to review your answer, the AI literally hallucinates a mistake. It just invents a totally flawed logical constraint about sets of yogurt and forces itself to rewrite the answer to $37.50. It literally corrects itself into a total failure. But wait, because it actually gets worse. There is another massive trap the researchers uncovered, and it's called the prompt design trap. You see, some previous studies claimed that self-correction loops were incredibly powerful for complex tasks, like constrained writing. But they were basically hiding the ball from the AI on the first try. Here is exactly how this trap works. In previous research, scientists would give the AI a suboptimal initial prompt. For example, they'd give it 30 random words and say, write a story. But they intentionally wouldn't tell the AI that it had to use all 30 words. Unsurprisingly, the AI would miss a few. Then, in the self-correction step, they would say, hey, you missed these specific words, rewrite the story. Boom. The second attempt obviously looks like a massive improvement, but this new paper proves that if you just give the AI a strong, detailed prompt on the first try, like telling it up front, write a paragraph that includes all of these concepts, the AI hits an 81.8% success rate right out of the gate. In fact, if you apply intrinsic self-correction after a genuinely good prompt, the performance actually drops again. Section 3, Implications and the Payoff. We've seen the intuition and we've exposed the traps, but now let's look at the hard benchmarking data. When forced to use intrinsic self-correction without that secret answer key, GPT-4's performance on the GSMA-K math benchmark drops from 95.5% down to 89%. It actually gets worse, and it is absolutely devastating for Llama 2. Its accuracy literally plummets from 62% all the way down to 36.5%. Across the board, looking at top models and top datasets, asking the AI to self-correct its reasoning intrinsically literally degrades its capability. So what are the real-world implications of this for the next 12 months of AI development? Well, it completely changes how we need to build software, robotics, and daily AI agents. We absolutely have to stop hoping the AI will magically fix itself in a vacuum. The real solution, the only solution, is hooking the AI up to external reality checks. If an AI writes code, it needs a code executor to compile and run it. The error message it gets back is that external feedback. If it answers questions, it needs to query an external search engine to verify facts against the real world. It needs calculators for hard math verification, and of course, human verifiers for actual ground truth alignment. We have to build external tool use into the very core of these models.
And this line from the DeepMind and UIUC researchers sums up the whole thesis. Expecting these models to inherently recognize and rectify their reasoning mistakes is overly optimistic so far. It's a blunt but necessary reality check for the industry. If large language models can't reliably grade their own homework without help, we have to rethink autonomous agents from the ground up, starting with what grounded in reality actually means for each one. So here's the thought I want to leave you with. If AI needs an anchor to external reality to genuinely self-correct, what external tool do you think becomes the most critical piece for unlocking the next real leap in capability? Let that sink in.